Hydrogen fuel cells offer clean and sustainable energy for cars, shipping vehicles, forklifts, and critical emergency backup power. Their only emission is water vapor. Widespread use of hydrogen fuel could greatly reduce human dependence on oil and traditional combustion engines, which produce greenhouse gases. But there is a hurdle that the industry and consumers still face that limits the use of hydrogen fuel cell technology. Contaminants, if they make their way into the fuel, poison the platinum catalyst inside the fuel cell stack.
Carbon monoxide, a well-known fuel contaminant, adsorbs onto the surface of platinum and lowers hydrogen dissociation, inherently reducing performance.
High concentrations can reduce the power to negligible output or even zero output in minutes. Impurities, like carbon monoxide, can infiltrate the hydrogen fuel at fueling stations. The contaminants then make their way unknowingly to the consumer. This results in reduced fuel cell lifetime or an inoperable vehicle or device.
There is an urgent need for an inexpensive, reliable device that can alert hydrogen fuel suppliers, refueling station owners, and the consumer when the hydrogen fuel is out of spec.
Current purity sampling methods for hydrogen fuel stations involve sending a sample off-site for analysis, and this could take weeks to get the results.
This warning has to come within minutes to prevent multiple vehicles from damage or entire fleets from becoming contaminated.
Researchers at Los Alamos National Laboratory partnered with Skyer and H2 Frontier to create a new type of hydrogen fuel impurity sensor and a new detection approach.
Our technology is a device that uses identical components as a fuel cell, but unlike the fuel cell, it has to operate without oxygen and water. Our device works on hydrogen samples extracted from the hydrogen refueling station. It behaves like an electrochemical pump, using a sensitive working electrode and a stable reference electrode. We monitor the working electrode performance and become alerted when its performance falls below our threshold.
So instead of contaminants poisoning potentially thousands of expensive fuel cell stacks before the problem is detected, a single inexpensive sensor is poisoned, and the sensor can readily be regenerated in seconds using basic electrochemistry principles.
We've spent several years compiling experimental results to help improve response time and sensitivity in our device. And as we anticipated, our technology has been verified and tested in actual field trials by others.
No simple sensor technology to ensure hydrogen fuel quality presently exists that can offer the near real-time results at such an affordable price. Our sensor technology makes it possible to overcome the technology gap between what could be possible with hydrogen fuel cells and their adaptation for widespread use. The electrochemical hydrogen contamination detector will protect the future of zero-emission fuel cell energy.